So here we are trying to estimate the repayments on a mortgage. In this example, someone borrows €120,000 with an interest rate of 5% for 30 years, and the payments are made on a monthly basis. The payments were calculated using a present value annuity technique. The results show that the repayments are €644.19 per month, and below here you can see a table illustrating the entire repayments over the life of the mortgage, where there's 360 payments. The table on the right here shows the results from Microsoft Visual Studio that used to verify the results using C++. And as you can see, the results are consistent with those found over here on the left. The present value of a bond was then calculated. The bond had a face of 1,000, coupon rate of 6%, an interest rate of 5%, so it's a premium bond, and a maturity of 10 years, and a coupon of 60. A breakdown of the coupon and cash flow payments is shown here, and VBA code was also used to calculate the present value of the bond. C++ was then used to verify the results calculated in VBA. A sensitivity analysis was then performed on the bond. The graph shows an inverse relationship as when interest rate increases, the value of the bond decreases, or the present value of the bond decreases. Sensitivity analysis was also performed of the bond price to change in the interest rate and maturity. The graph shows that all maturities with an interest rate of 6% intersect, because at this point the bond is a par bond as the interest rate is equal to the coupon rate. The yield to maturity of a bond was then calculated using the bisection technique, and the parameter inputs are shown here. However, we did not know the interest rate. That's what we were trying to estimate. So using VBA, the internal rate of return formula was used to estimate the yield to maturity, and it was found to be 5% for this bond. Bisection technique is essentially an automation of a grid search technique. The duration of the same bond was then calculated, where the duration is essentially a measure of bond price sensitivity. It was calculated using VBA here, and in Excel, shown in this table here, where the result is down here. And through C++, he also estimated it to verify our results. All results were found to be consistent. The duration was then estimated by replicating the Hopewell and Kaufman technique using the Macaulay duration formula. The table shows the effect of increase in maturity and coupon rate has on the duration of the bond. The results show that the duration does not increase in a linear fashion consistent with the maturity. When the maturity increases, the duration seems to increase at a decreasing rate. The duration value for a coupon rate of 2% and maturity of 100 years is then verified using C++, and the result, as you can see here, is consistent with the value found in the Hopewell and Kaufman table. Black 1976 model was then used to calculate the value of a call and put on a bond futures. The parameter inputs are shown here. Sensitivity analysis was then performed on the volatility and time. The two graphs show that as the time and volatility increase, so does the value of the call. The Black 1976 model was then used again to calculate the value of a call and put for an interest rate collar. A calculator was constructed here to calculate the Greeks values for the call and the put. The Greeks was then calculated again here in order to graph the Greeks below. However, the formula for the Greeks here is based on the Black-Scholes model. However, by setting the value of the dividend yield, which is the Q value here, equal to the interest rate here, the Greek output converges to the same results of the Black 1976 Greeks. And the results from the Greeks were then mapped out, as you can see here. The binomial model was then used to alternatively work out the value of the call. The binomial model is based on code taken from the Cox, Ross, and Rubinstein model. The code calculates the value of the option using the above parameters and becomes more accurate with a greater amount of steps. And the binomial price using 10,000 steps is shown here. And as you can see, it is converged to the results from the Black-Scholes model. However, the binomial model does have its limitations, as when you increase the number of steps, it becomes very computationally intensive on the computer.